is moles and Avogadro number. Okay? We did it yesterday, this man constantly watching us. You know his name, Avogadro, Amedeo Avogadro, Italian scientist. What is the definition of Avogadro number? The number of particles in 1 mole of any substance is fixed and it is called Avogadro number. Okay? And what is the symbol of Avogadro number? Capital N, small a as a subscript. What is its value? Anyone of you remembers? Right, 6.02 into 10 to the power 23 particles. Atomic mass of carbon. You know its chemistry class? Grade 9. And you see your lecture number 15. What is the atomic mass of carbon? Gram atomic mass of carbon? 12 gram. You call it 1 mole. 1 mole of carbon. Gram molecular mass of water, H2O. How much? You know it. H2O. What is the atomic mass of hydrogen? 1. How many hydrogens? 2. 6. Oxygen 16 into 1. 2 plus 16. 18 gram. So what is the molar mass of water? 18 grams. So we write here 18 gram. It is also called 1 mole because we have studied that 1 mole of any substance means its atomic or molecular mass. If I say atomic mass of magnesium, it's an element. Atomic mass is 24 gram. It is its atomic mass, we call it 1 mole. Alright? Or we say gram molecular mass of sugar. What is the formula of sugar? C12H2O11. We found its mass yesterday also. It is 342 grams. Repeating that if you are attending the class for the first time, you won't be able to understand it. Science, chemistry grows vertically. Whatever you know today, tomorrow's topic will be based on yesterday's topic. So this is called 1 mole of sugar. Okay? And formula mass of salt, common salt, 58.5 gram. We call it 1 mole of NaCl. So what have we done here? We have taken atoms, molecules, ionic compounds, like these two are the atoms, carbon and magnesium, water and sugar, these are the compounds. This one is the ionic compound, that is why we didn't write molecular mass, but we wrote here formula mass. Atomic mass expressed in gram, 1 mole. Molecular mass expressed in gram is called 1 mole. So what was the definition of 1 mole? Atomic mass, molecular mass, formula mass, expressed in gram is called 1 mole. Okay. So if I say 1 mole of carbon, 12 gram. If I say 2 moles of carbon, you will double it, 24 gram. If I say 3 moles of carbon, 36 gram, and so on. 1 mole of water, 18 gram. 2 moles of water, 36 gram, and so on. Okay? Right? Last topic what we did related to it. So 12 gram of carbon and 18 gram of water. So here I have 18 gram of water. This is 18 gram of water. All right? This is salt. 1 mole of salt. 58.5 gram salt. Common salt. This is sugar. How much? 1 mole of sugar. 342 grams. Magnesium. Magnesium wire. How much? 1 mole of magnesium, 24 gram. Carbon. 12 gram, 1 mole of carbon. So what I did here, I have taken 1 mole of different substances. 1 mole of sugar, 1 mole of water, 1 mole of carbon, 1 mole of magnesium, 1 mole of common salt. So here we focus that first thing, the value of 1 mole is not fixed. 1 mole of carbon means 12 gram, 1 mole of water means 18 gram, 1 mole of sugar means this. What is the point here? If we start counting, this is 1 mole of water means 18 gram of water. If we start counting how many water molecules are present in it, then in all of these 6.02 into 10 raised to power 23 particles means 18 gram of water contains 6.02 into 10 raised to power 23 water molecules. 342 grams of sugar contains 6.02 into 10 raised to power 23 sugar molecules. 12 gram of carbon contains 6.02 into 10 to the power 23 carbon atoms. Sodium chloride, 24 gram, 1 mole. It contains how many atoms of magnesium? 6.02 into 10 to the power 23. So what was the definition of Avogadro number? What was the definition? See, here is the definition. You can see the number of particles in 1 mole of any substance is fixed and is known as Avogadro number. All right? Its value is 6.02 into 10 to the power 23. It means 1 mole of any substance contains a fixed value called Avogadro value. And it is quite obvious that instead of having 1 mole, if we have 2 moles, obviously the value would be doubled. If we have 3 moles, the value would be multiplied by 3. It will become thrice, and so on. Okay? So what is the Avogadro number here? 6.02 into 10 to the power 23. Now, as I told you that we will do board work, I hope you have understood it conceptually. It is very easy to memorize, to learn, to rectificate the definition. But I am trying to clear the concept here. Look at the board. Number of particles if I have 18 gram of water, I have 6.02 into 10 to the power 23 water molecules. If I have 36 grams, then I will have double of it. Could be thrice of it. So, can we write, instead of writing so big number, can we write like this? What is this? Number of moles. It could be 1 mole, it could be 2 moles, it could be 3 moles. So that's why you write here N. If I ask, I have 5 moles of sugar, how many molecules it has? You said, sir, multiply 5 by Avogadro number. If I say, I have 10 moles of carbon, you say, then I ask, how many particles it has, how many atoms it has? You say, so just multiply 10 by Avogadro number 6.02 into 10 to the power 23. If I have 3 moles of carbon dioxide and I ask how many molecules it has, how many particles it has, how will we find it? 3 multiplied by 6.02 into 10 to the power 23. So here comes a formula that if you want to know the number of particles, we will multiply the moles by the Avogadro number. Okay, now let's make the thing different. What is N? N means number of moles. How many of you remember the formula to find out the number of moles? Number of moles means N. Okay, you can write here moles is equal to, what was the formula? Given mass upon atomic or molecular mass, or simply you can say molar mass. This is the formula. How can we I write it simply in a simple way? Number of moles represented by small n. N means number of moles is equal to given mass upon atomic or molecular mass. Or simply you can write here molar mass, or you can write directly here formula mass. So what is the value of N over here? The value of N is given mass upon atom molar mass. So substituting this part over here, N, instead of writing this N, can we write this value? Yes, we can. So the final formula to find out the number of particles will become, we'll not write N, we'll write given mass upon atomic or molecular mass. into Avogadro number. This is the formula that you are seeing on the screen. So you are going to use this formula. That okay? This was formula number 1 of your chemistry, and this is your formula number 2. This we have used, we have seen its applications. We have used this formula in the various numericals, and this one is the new one. So what is the addition today? This formula. So what are you going to remember? The number of moles we can find out by using that formula, given mass upon molecular mass, and one minute. Number of particles means atoms, molecules, ions, all. Means you can write this as number of atoms, like you say fruits. Okay, it's a general term. Which fruit? Apples. Which fruit? Mangoes. Which fruit? Cherries. Similarly, particles is a general term. Now, what type of particles? Could be atoms, could be molecules, could be ions. So we can rewrite it for atom. Number of atoms, if we want to find out number of atoms, we can write it like this: given mass upon atomic mass into Avogadro number. The same formula can be written for number of molecules as number of molecules given mass upon molecular mass into Avogadro number. Okay? Question. Suppose we have 100 gram of water. I am supposing it is 100 gram water. 100 gram water is there, and we want to find out that how many molecules it has. So I'll write the question. Calculate the number of molecules. One can write here particles also. Number of molecules in 100 gram water. I repeat, we have suppose 100 gram of water and we want to know how many molecules it has. So what is the data here? Data means what is given to you and what is asked. Mass of water is given. How many grams of water do we have? 100 grams. Remember, whenever it is asked to find number, like number of molecules, like number of atoms, then one thing is given. What is that thing? Avogadro number. Okay? So the value of Avogadro number, all of us know, is 6.02 into 10 to the power 23. Okay? And what is asked? Number of water molecules is to be calculated. Solution. Water is a compound or an element? It's a compound. So we have to show the working of Molecular formula, molecular mass means first we'll find the molecular mass of water. All of you know it very well. H2O. 1 is the atomic mass of hydrogen. How many hydrogen? 2. 16 times 1. You know it very well. I'm not explaining. So it will become gram molecular mass 18 gram. Next. What is the formula? Just told you that number of particles. What kind of particles we have to find here? Number of molecules. That's why I write here number of molecules is equal to given mass upon molecular mass into Avogadro number. Substitute the values. What is the mass given to us? 100 gram. What is the molecular mass of water? 18 multiplied by 6.02 into 10 raised to the power 23. So now we will use what? We will use the scientific calculator. We will multiply first 100 by 6.02 into 10 raised to the power 23. Okay? So how will you enter into the calculator? Look at the board over here. If you don't know, you will write 100 multiply 6.02. Then you will press the button of EXP. Either it is the button of EXP exponent, or it could be written like this. Okay? You will enter 6.02, then press the button exponent, or this button if you have in your calculator. Then you will write 23 only. And then you will press execute. When you execute it, you will get the answer 6.02 into 10 to the power 25 divided by 18. Okay? Now you will divide the answer, whatever will be the answer that you get, by 18. So you will get 3.33 into 10 to the power 24. And then what will you do in the result? You write in the result that 100 gram water contains 3.33 into 10 to the power 24 water molecules. I repeat the question here. You have a particular quantity of water, 100 gram, and you have to find number of molecules in it. You can make the questions by yourself. Like, calculate the number of molecules in 700 gram of sugar. Calculate the number of molecules in 150 gram of glucose. Okay, or you can write like this: calculate the number of atoms in 100 gram of water. I'm sorry, 100 gram of any element. All right. Given mass, whenever it is asked number of molecules, this is understood. It will be given to you. Number of molecules to be found out. First, we found the molar mass, the formula. We substituted the values. The value of given mass 100, molar mass is 18, 6.02. We multiply these two. It doesn't affect. Either you first divide and then multiply, or you first multiply or divide one and the same thing. You will get the same result. Okay? So let's wind up the class. That's all for today. Thank you so much. Take care.